In this video, we're going to go over how to solve problems that involve acid-base indicators. So, indicators, what they are weak acids in equilibrium with their conjugate weak bases. A conjugate weak base is just like the acid with one less hydrogen, because acids like to give their hydrogens away, right? So, for example, if we had, I don't know, let's say HCl or hydrochloric acid reacting with water, and that would give us hydronium and chloride ions. So this would be our acid, and then our conjugate base to this acid would be chloride, because it is like hydrochloric acid just with one less hydrogen. So you could kind of think of the word conjugate kind of like it's pair. So acid and conjugate bases, they are pairs. Okay? The only separation between them is one hydrogen. So just kind of FYI with what conjugate bases are. There's also conjugate acids, which again are paired up with bases, and it's just the base with one more hydrogen instead of one less. Okay, so indicators, they're just weak acids in equilibrium with their conjugate weak bases. The acid and base form different colors. Okay, so essentially, like if we're going back to this example, it's not perfect because hydrochloric acid and chloride ions don't have two different colors. Okay, but essentially what they're saying is, okay, the acid form is one color. We'll say just with color-wise, let's say it's pink. It's not pink in reality, but let's just say. Okay, and they're saying, okay, the conjugate base of the indicator is some other color. So let's say blue. Okay, that's not in all actuality what's happening here, but I'm just trying to make this visual for you. Okay, so we use abbreviations to show the names of indicators because otherwise they get fairly long, and you can find them not necessarily in your periodic table, but in your data booklet. So let's cross that out and write data booklet. Okay, so if we go to our data booklet here, where we're going to find them, like the indicators, is on page 10. Okay, so for example, methyl violet, the acid abbreviation would be HMV, and then the conjugate base abbreviation would be just MV1-. Okay, so this is our acid, and we can tell because it has a hydrogen in it, and then this is our conjugate base. Okay, so most of these are just listed with the acid first and then the conjugate base second. Okay, another thing that you're going to notice here is that in addition to the abbreviations, we're given pH range and color changes. Okay, so what is going to be important for us to be able to tell is like how colors are going to change. So that means we're going to need to know our color theory here. So what I'm going to do is I'm just going to draw a circle and then an X through it and then a horizontal line. Okay, so this will be our color wheel, and we'll just do a quick revision of what the color wheel looks like. So first, I'm just going to plop in that we've got blue. And just in case there's anybody colorblind, I'm going to write the color blue, or the color right beside where it is. Okay, and then let's go with our primary colors first, and then we can fill in our secondary colors later. So here I'm going to put yellow. And then we're going to do red. Okay, so the primary colors kind of make the color wheel look like a beach ball. Now we're going to do our secondary colors. So we just got to ask ourselves, okay, if we mix red and blue together, what do we get? Obviously, it's going to be purple. When you mix yellow and blue together, you're going to get green. And then when you mix yellow and red together, you're going to get orange. Alright, so why is going over the color wheel important here? It's because when you look at each of these pH ranges, so the left-hand number corresponds to the left-hand color. Okay, so 0 and below, maybe this isn't the best example, but this is going to be how it's going to be for all of them. So 0 and below, that's going to be yellow. Okay. For blue, that's going to be at 1.6 and above. What's going to be in between here is going to be the in-between color between yellow and blue. So in between 0 and 1.6, methyl violet is going to be green. So that's why we needed to go over our color wheel just quickly here, because you do need to know your primaries as well as your secondary colors just to figure out what color your indicator is going to be. Now, again, the reason why there's two different colors, okay, is because the acid is going to be one color, or the acid form of this indicator is going to be one color, whereas the conjugate base of that same indicator is going to be a different color. So this is saying that the acid version of methyl violet is going to be yellow, whereas the conjugate base form of methyl violet is going to be blue. Okay, so heads up on that, and we can write that out here. So this is the acid form, or we'll just call this the acidic form, and this is going to be one color. I'm not going to specify which color just because it depends on which indicator you're using, whereas the conjugate base, which is here, is going to be some other color. And again, I'm not specifying because it just depends on what indicator you're using. So when an indicator is in the presence of an acid, so you have your protons around or your H plus ions around, it assumes the H or the acidic form of the indicator and it shows its acid color. When an indicator is in a base, so hydroxide is present in the solution, the indicator is going to assume its basic form, and you're going to see a basic color which is different than the acidic color. So we're going to use the indicator chart to tell us what colors indicators will be at certain pHs. So for example, we're going to talk about orange 4. So if we look at our acid-base indicators table here, orange 4 is right here. Okay, so remember, left-hand color corresponds with left-hand number. So at 1.4 and below, the acidic form of this indicator will be present, and so it will be red, because that's the color of the acidic form of this indicator. So what I'm going to do here is I'm going to color this in red. So this is red. And then at 2.8 and above, so let's check this out. So right-hand color, I'll use a different color for this. Right-hand color corresponds with right-hand number. So what this means is at 2.8 and above, we will have the conjugate base form of this indicator. And it is yellow. So let's go back and color this in. Now, in between the acidic form of the indicator and the conjugate base form of the indicator, in between this range of 1.4 to 2.8, we're going to have a mixture of the acidic form of the indicator and the conjugate base form of the same indicator. So it's going to be the in-between color, which is going to be orange. Okay, so that is going to be how you use this table. So again, your left-hand color corresponds to your left-hand number. Your right-hand color corresponds with your right-hand number, and in between will correspond to the in-between color. Okay, so this table, once you understand that, this table is pretty easy to use. So, some more examples. When will chlorophenol red be yellow? When will it be orange? So let's take a look. So chlorophenol red, that's the name of the indicator there. So let's get rid of this stuff here and let's find it. Okay, so we have chlorophenol red. Okay, and we're asked, when is it going to be yellow? Okay, well, it's going to be yellow at 5.2 and below. So let's just kind of break this down here. So chlorophenol red, that is the name of the indicator. And then these are going to be the colors. Okay, so chlorophenol red is going to be yellow at a pH of 5.2 and below. So I'm going to just start kind of visualizing this. So pH of 5.2 and below, that's what this arrow is supposed to mean. So answer to this, at a pH of 5.2 and below. Once we get to more complicated questions with indicators, this is going to make sense why I'm kind of drawing out the answer a bit more visually. And when chlorophenol red is going to be orange, well, orange is the in-between color between yellow and red. So then orange is going to be in the in-between range between 5.2 and 6.8. So let's write that out. And I'll use a different color so it's easy to see that I'm answering two different questions. So 5.2, 6.8. So pH between 5.2 and 6.8. All right, next question. When will bromothymol blue, so that's the name of the indicator right there, when will it be blue? So that's the color. So it's going to be blue let's read this. So bromothymol blue, that's the next one here. So let's get rid of all this stuff. So bromothymol blue will be blue. So remember, right-hand color, right-hand number. So at 7.6 and above. So what this means is that bromothymol blue could be blue when it's put into a solution that has a pH of 7.8, 8, 9, 10, all the way up to 14. That indicator will be blue at all of those pHs. Okay. Now, where it's going to be green, so I'm going to use a different color, and we'll put our answer over there. Well, green is the in-between color between yellow and blue. So then our pH is going to be the range between our two values here. So it's going to be green between 6.0 and 7.6. I'm going to abbreviate between to B/W. Okay. Now, in the third question here, we have thymol blue, and we're asked to figure out all the colors. Now, since it is a diprotic indicator, this is actually a special indicator that has a lot of different colors to it. So if we look at thymol blue here, which is right here, okay, notice how there's two lines for it. So I'm going to get rid of this so that it's a little bit clearer, and then we'll figure this out. Okay, so to start off on the lower end of the pH scale, thymol blue is going to be red at 1.2 and below. Okay, it's going to be yellow at 2.8 and above. So let's get that down. So let's use black here. So 1.2, and then our other number was 2.8. Okay, so it's going to be red below 1.2. So there we go. And then 2.8 and above, it's going to be yellow. But before I draw in yellow, I just want to check out the next line. Okay, so it says it's going to be yellow at 8.0 and below. Okay, so what this means is it's yellow between 2.8 and 8. So let's make sure to capture that. So this is not going to be to scale by any means. And I'm going to move this over a little bit. So this is going to be yellow. Now, in between 1.2 and 2.8, well, it's going to be the in-between color between red and yellow, which is going to be orange. Okay, now let's check out the rest of this. Okay, so it's going to be blue at a pH of 9.6 and above. So let's capture that. So 9.6 and above, it's going to be blue. And then between 8 and 9.6 is going to be the in-between color between yellow and blue, which is going to be green. And there you have it. Okay, so now we're getting on to a bit more interesting questions using indicators. Okay, so question number 4, we have a single solution turns methyl red, so that is the indicator name, and bromothymol blue, that's the indicator name. So both of these indicators are turned yellow, so this is the color. What is the pH of that solution? All right, so this is where the number line comes in really handy. Okay, so let's take a look at methyl red and see where it is. Okay, there's methyl red right here. Okay, so methyl red, we wanted to figure out when it's yellow. So it's yellow at 6 and above. So that's why I'm going to write out 6 and above. Maybe I'll write this as one color here just to represent methyl red. Okay, and I'm going to write that this is the indicator. And then I'm going to use pink for bromothymol blue. Again, this is the indicator. So when is bromothymol blue yellow? So let's find out. So bromothymol blue is right here, and it is yellow at 6 and below. So let's write that down. Okay, so essentially you're just looking for either where there is overlap or where two arrows, the closest two arrows are pointing towards each other. Now, since there are no closest two arrows pointing towards each other, we got to go with the overlap area, which is going to be right at 6. So the pH of the solution is 6 exactly. All right, next one. What is the pH range? So we're going to have an answer that goes number to some other number, okay, of a solution that turns both chlorophenol red, so that is an indicator name, and methyl orange, that's the indicator name. Both of them turn yellow, which that is going to be the color. Okay, and we're also looking for methyl red, which is the indicator name. When does it turn orange, which is the color? Okay, so once again, number line is the way to go when solving this. Okay, so let's start with chlorophenol red and where it is yellow. So let's get rid of this. So where is chlorophenol? Chlorophenol red is right here. Okay, so where it's going to be yellow, so left-hand color, left-hand number. So 5.2 and below. So let's write that out. So I'm going to go 5.2 and below. Okay, now our next one, that's methyl orange. When does it turn yellow? So we were using blue for methyl orange. So methyl orange is right here. yellow, so right hand color, right hand number, so 4.4 and above. So I'm going to go, sure, 4.4 and above. Okay. Now we got to figure out, okay, where is methyl red, orange? So methyl red, where to go? Right here. So orange, that's the in-between color between red and yellow. So it's in between 4.8 and 6.0. So we're going to have to squish a little bit, but that's okay. This is not to scale. So 4.8 to 6.0. Boop. Boop. Okay. So this is why I said one of the methods that you can use to figure out the pH is you're just looking for the two arrows that are closest together and pointing towards each other. Okay, so our indicator range, that's going to be right in here between 4.8 and 5.2 because those are the two closest arrows that are pointing towards each other. Okay. So the reason why it's like that is because, like, we can't say that the range is beyond 5.2 because then chlorophenol red would not be yellow because it's only yellow at 5.2 and below. Right? We can't go any lower than 4.8 because then that would mean that methyl red will not be orange at a pH lower than 4.8. So that's why you have to go with the two arrows pointing towards each other that are closest to each other. So for our answer, pH range is, I'm going to start with a lower number, so 4.8 to 5.2. For the next question, what is the pH range of a solution that turns orange 4, which is the indicator, yellow, that's the color, methyl red, which is the indicator, red is the color, methyl orange, that is the indicator, red is the color. Okay, so number line, and then we'll start off with the first indicator mentioned. Okay, so let's start off with orange 4. Let's figure out where that turns yellow. So orange 4 turns yellow, so right hand color, right hand number, so 2.8 and above. So I'm just gonna go right here and above. Okay, so that's the first one. Now we're on to methyl red. It turns red. So methyl red is right here, red, so at a pH of 4.8 and below. So I don't know, I'm gonna stick it right there, 4.8 and below. Okay, so that's methyl red done. Now we need to do methyl orange, and it turns red. Methyl orange is right here, red, right hand color, right hand number, so 3.2 and below. So I'm gonna have to squish that in. So 3.2 and below. All right, so the two closest arrows that are facing each other are between 2.8 and 3.2, so that's the indicator range. Or sorry, that's the range of the pH based off of the evidence we got from our indicators. So pH range 2.8 to 3.2. Done. So I'm just going to write out what I've been saying here. Look for the closest arrows that point towards each other. So that'll be what you're looking for 99% of the time. And the only other option would be if you have this situation, just pick where they overlap. So in this case, it was just at a pH of 6 exactly. Okay, so for questions like these, for your answers, I would expect you to show your number line as well as your statement as to either what the pH of the solution is or the pH range is.